Hello, thanks for clicking, and welcome back to another Prenarculus production, another exciting event. Today we're going to be talking about section 5.5, at least part of it, which is the double angle formulas. Double angle formulas can be found using the sum and difference formulas that we learned in the last section. We're going to see how that works real quick for a couple of them, and then we're going to do some problems, and off you'll go. All the problems you'll see today are problems that are very similar to ones that you've done before. Okay, all right, so what we want to do is to be able to calculate the sine of 2u. That's what I want to be able to do. All right, to find the sine of 2u, well, really, that's the sine of u plus u, right? Because u and u is 2u. But this is one of those sum formulas that we just learned. So you can do this by finding the sine of u, cosine u, plus cosine u, sine u. Okay, now these two are like terms. These are in the wrong order. Okay, these are in a different order than these, but it doesn't matter. You can multiply in any order that you want. So we can combine these as like terms, and we'd get 2 sine u cosine u's. This is what sine 2u is equal to. So sine 2u is equal to 2 sine u cosine u. That's a double angle formula. All right, that's one that you're going to need today. That's where it comes from. Okay, all right, let's do the same with cosine. Okay, and then tangent, I'll just put it up there, but you can figure it out pretty easy the same way. So cosine 2u, so that's u plus u, same thing. So the sum formula for that would be cosine u minus sine u, sine u. Well, cosine times cosine is cosine squared. Sine times sine is sine squared. Cosine squared u minus sine squared u. That is one of the identities for cosine 2u. Okay, that's the double angle formula. Now, there's actually two more double angle formulas for this. All right, I'm going to show you where they come from. It's pretty easy. They come from the Pythagorean identities. So you could rewrite cosine squared as 1 minus sine squared. And now you would have 1 minus 2 sine squared u. That's another identity for cosine 2u. Okay, that's another way to write cosine 2u. And a third way to write cosine 2u would be if you swapped out sine squared u and put a 1 minus cosine squared in its place. So I'm going to do it over here right next to it. So cosine squared u minus sine squared u. Okay, and then I'm going to swap out the sine squared and put a 1 minus cosine squared. All right, and then that would be, distribute the negative, you'd get 2 cosine squared u minus 1. So that's a third way to write cosine 2u. All right, so we're going to write them all up here momentarily, real quick. Okay, so that you have all three ways to write the identity. So cosine 2u is cosine squared u minus sine squared u. It's also equal to 1 minus 2 sine squared u. And it's also equal to 2 cosine squared u minus 1. All three of these are valid for this double angle formula. All right. And finally, we have the one for tangent. Okay, I'm going to write it here real quick. I'm not going to prove it to you. You could do it with the sum formula, the same way we did the other two. But you would get 2 tan u over 1 minus tan squared u. That's the formula for tangent 2u. Now, another convenient formula that you can use for tan 2u is you can write it as sine 2u over cosine 2u. Okay, sine over cosine here is tangent. All right, so you can use that as well. All right, so let's try a couple of problems that pretty much you've done before, but now we're just going to do them with some double angle formulas. Okay, so I'm going to give you, let's say you're given sine theta is negative 3/5, and theta is between pi and 3 pi over 2. I want you to find for me sine 2u, cosine 2u, tan 2u. All right. All right. So this is certainly not on unit circle. So we can make a triangle for it. So let's do that. Our angle is going to be in quadrant 3 between pi and 3 pi over 2. So angles in quadrant 3, going to make the triangle there. Sine is y over r. So the y coordinate's -3, r is 5. That tells me x is -4 if I use the Pythagorean theorem, right? But you're going left. So there's my triangle. All right, so now let's see what we can do with this. So now if I want the sine of 2u, write out your formula. It's 2 sine u cosine u. Oops, we're going to do theta. Sine 2 theta is 2 cosine theta, 2 sine theta cosine theta. Okay? All right, so now 2 times sine theta, sine is y over r, cosine theta, x over r. Stick a 1 underneath there and multiply fractions straight across. You'd get 24 over 25. So sine 2 theta is 24 over 25. Okay? All right, let's try to find cosine 2 theta. All right, let me get rid of this. Then we'll find cosine 2 theta. All right. And over here, we'll stick that sine 2 theta. And it should be thetas. Is 24 over 25. We'll use it later when we get tangent. Okay? All right, so now cosine 2 theta. You can use either formula, any one of the three. It doesn't matter. I'll just use the first one. I already have the triangle. All right? So cosine squared theta. So cosine theta is -4 over 5, and then I'm going to have to square it. Minus sine squared theta is -3 over 5, and I'm going to have to square that. So that's going to be 16 over 25 minus 9 over 25, which is 7 over 25. Okay, looks good to me. 7 over 25. All right, good. So we got cosine 2 theta is 7 over 25. Okay, now I can get tan 2 theta. Tan 2 theta is sine 2 theta over cosine 2 theta. So that's going to be 24 over 25 over 7 over 25. So now we can keep this, change this, flip this over. 24 over 25 times 25 over 7. Cross those out. You get 24 over 7. So my tan 2 theta is equal to 24 over 7. There's all three values. Sine 2 theta, cosine 2 theta, tan 2 theta. Okay? All things pretty much that you've done before. Make a triangle. Use the formula, write the formula out, and then go find the value. All right? Okay, so now this is something that's slightly different, I guess. So what I want you to do here is I want you to rewrite the expression with double angle formulas. All right, I'm going to show you what I mean in a second. You'll see. Okay, I want you to rewrite the expression with double angle formulas. So here's the first one. Let's try. 10 sine x cosine x. All right, I want you to rewrite this, but with double angle formulas. The double angle formulas would be like sine 2x, cosine 2x, tan 2x. Okay, so I'm looking for something that's similar to, looking for this to be similar to one of these. Well, sine 2x, I know that one. That's 2 sine x cosine x. That's actually really similar to this, but it's not exactly the same because what I have here is actually 5 times 2 sine x cosine x, right? I can multiply these in any order I want. I'm not distributing the 5 because these are all multiplied, so I can multiply in any order I wish. 5 times 2 would give me 10. So now in place of the 2 sine x cosine x, I can put a sine 2x. Now the answer that I have is in terms of a double angle formula. It says 5 sine 2x. So that's what your answer is going to look like. It's going to look like an answer that has either sine 2x, cosine 2x, or tan 2x in it. Okay? All right, so there's one example. We're going to try another one. Okay? All right, let's try another one real quick. Let's try cosine squared x minus a half. All right? Okay, so cosine squared x minus a half. if you go and look at your identities for all of these, if you look at the cosine 2x, there's an identity for it. We can rewrite it as 2 cosine squared x minus 1, which is very similar to this. I'm going to write it down here. Cosine 2x is really 2 cosine squared x minus 1. Okay? So how would we get from here to here? Well, this is what I want. I would have to take each side and multiply it by a half, right? If I multiplied both sides by a half, I'd have 1/2 cosine 2x equals, if I multiplied this side by a half, I would get, and distribute the half, I'd get cosine squared x minus a half. So that must mean that this is actually equal to 1/2 of cosine 2x. And there's your answer. Okay, that's written with a double angle formula in it. All right. Okay, so that's something that maybe is a little bit different. And now let's go and we're going to solve an equation real quick. Okay, we've already done this before. Solve on 0 to 2 pi. We are going to solve sine 2x sine x equals cosine x. All right, so first thing I'm going to do is bring over the cosine. I want to try to solve this. Okay, but you can't solve it unless it's equal to 0. But now I can't factor this. It doesn't factor or anything like that. But sine 2x, I can actually change this out, right? All right, so you can't take out sine x here. It's not like sine squared x. It's sine 2x. This is saying these two are different. They're not like terms. Sine 2x and sine x are two different things. This is like saying take the angle and double it. This is saying just take the angle on the unit circle. They're not the same, okay? They're not the same, all right? So I can't take anything out of here. I can't multiply these together, but I could take sine 2x and swap it out with its identity, which would be 2 sine x cosine x, which I kind of like because now everything just has the same angle in it, x. They're all x's. So now I can multiply in any order I wish. So I'm going to multiply the sine times the sine, of course. I'll get sine squared. Cosine x minus cosine x equals 0. Now I can factor out a cosine. It's in common in both. So I'm going to take out cosine x. I'll be left with 2 sine squared x minus 1 equals 0. All right, now I can split them and solve them. So if I split them, I'll have cosine x equals 0. And then I'll have 2 sine squared x minus 1 equals 0. All right, so this one still has to be solved. So sine squared x equals a half, right? Add 1, divide by 2. Take the square root on both sides. So sine x equals plus or minus square root 1/2. Okay, took the square root on both sides. You can rationalize, right? Plus or minus, it would be 1 over square root 2, which is going to be plus or minus square root 2 over 2. That's something from the unit circle, so that I can work with. All right, so cosine x is 0. Now cosine 0 here and here, so that's pi over 2 and 3 pi over 2. Okay. Sine x is root 2 over 2. Well, sine is positive or negative in every quadrant. So we're going to get 4 answers from this thing. 4 answers. Pi over 4 is the reference angle. So we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All the pi over 4s. So we have 4, 5, 6 answers. There's 6 answers to this problem. Okay? So that's how you can solve an equation with double angle formula. Most of the time it involves you, or in this case, it involves you swapping out that double angle formula, all right, and putting in the other formula in its place, okay, what it's equal to, and then working on it from there. All right, as always, thanks for clicking. Like and subscribe.